Hello, today we'll be presenting our sixth semester project, an application for United Airlines Association. The group consists of two, Dumitru and myself, Daniela. The purpose of the project is to examine the concept of cloud computing and the strategic consideration for using cloud computing. In the analysis part, beside already predefined functional requirements of loading data from the cloud, displaying multiple data types in table or graphs, and having the application available on a browser from anywhere in the world, a set of non-functional requirements have been defined. This is to have the backend application written in ASP.NET Core using C# and the React application as a front-end application. For the design part, a system architecture diagram was made as following. The system has an Azure SQL database on an Azure SQL server, from which the web application and the function application retrieve data, transform it, and expose it via HTTP endpoints. The React application consumes the endpoint information and displays it on a web browser.
We have applied DevOps practices in our process in order to unify software development and software operations so that we could build, test, and release our system components at a faster and more reliable pace. DevOps tools have been used in the development process for project management, cloud hosting, version control, and continuous integration and deployment. For project management, an agile approach was used for tackling the requirements of the project by splitting them into multiple smaller tasks. The outcome of the tasks was analyzed and tested to assure true completion of the original requirement. GitHub Kanban was used to track tasks and their progress. Our cloud provider of choice was Microsoft Azure. This decision was made due to the team's previous positive experience with their services and customer support. Among the previous mentioned, the architectural setup that can be designed within their system can be arranged in a simple manner regardless of the number of resources created. Many features are available for further configuration and troubleshooting.
For version control, GitHub was used as the team was more familiar with. Also, it has a project management board for assigning tasks, Git action for continuous integration, and version control itself. The continuous integration and the continuous delivery setup for the project. The system parts are split into three different repositories as shown in the picture. Web app and the React app have Git actions for continuous integration and delivery to Microsoft Azure. For the function app, a manual deployment was performed. In the picture are presented the Git action workflows for React app continuous integration and delivery. Each commit to our main page is executing the Git action. During execution of the build and deploy job, application was built, tested, and deployed to Azure portal.
Our system is split into three separate applications and the database. As Daniela previously mentioned, all of these components are deployed in the cloud. An Azure SQL database instance was created within our cloud provider. By making use of Microsoft SQL Server Management Studio, the data from the provided CSV files was migrated into this database. We have implemented a web API that retrieves and alters data from our database in order to expose information that fulfills most of the requirements. Using Swashbuckle's Swagger, an automatic documentation of the API is generated. For the requirements not fulfilled by the web API, an Azure function application was developed. Some of the functions retrieve basic data exposed by the API and process it to its needed form, while others also maintain a direct connection with our database.
The front-end application written in React calls the endpoint and fetches data using Axios. Then, using Chart.js library, it is displaying data in a graph or in a table using Material UI.
Testing was performed on all of our applications. For our web API, black box testing was performed by making HTTP calls using either Postman or Swagger. For white box testing, in few words, everything was unit tested. External libraries were used for setting up the test environment, such as mock and nbuilder. For our Azure function app component, we only used black box testing methods. Requests were sent to the endpoints exposed by the functions. The response data was then analyzed manually to ensure correctness.
The React application was tested in two ways. First is snapshot testing to check how the components change from one commit to the other, and to ensure that the components do not change unexpectedly. Second is the end-to-end testing using Cypress to make assertions and execute commands on page components in a live manner. For the project, regarding the project future, the following improvements could be made. First one is the authentication and authorization, improving course policy and error handling, also updating logging and fixing some React application bugs. In conclusion, the requirements were fulfilled, both functional and non-functional. We have an application structure where the system is split into 3 apps that are hosted on Microsoft Azure Cloud, having CI/CD pipelines and version control. Now on goes the live demo of our application.
Okay, so we will start the live demo by showing you how the Swagger UI interface works for our application. So basically, we only get a list of endpoints. And when we expand one of the endpoints, we have here an example of the model that we will receive. And also we can just press try it out and execute the endpoint. And in here, we get the required data from the endpoint. And this is, as I previously mentioned, made for all of the endpoints created. And also on the bottom, we have all the models that we can receive as a response.
For the React application, we can see that we see a lot of data. There are different kind of graphs for different kind of information that we needed. Also, if you tackle one of the legend points, you can see how the information is displayed just for that particular, for example, destination or origin. For weather, we can see more interesting graphs that are provided. These are some weather observations. For example, this graph is for each of the origin in a table, and you also can see how the information just goes on and off depending on you toggling in and out. There also are made some graphs for planes, so you can see also planes, graphs, and some tables. This is it. Thank you for your attention.
Thank you.